lesson is over proving lines are parallel, and we're going to be using the converses of the angle pairs that we learned last lesson. So the objective, if you want to pause this because I'm going to go fairly quickly, you can. We're going to prove two lines are parallel using corresponding angle theorem, alternate exterior angle theorem, alternate interior angle theorem, same side interior angle postulate, and it's the converse of all of those. We'll also be using those theorems and postulates to find angle measurements. So let's first talk about what a converse is. A converse is when you switch the hypothesis and conclusion. So in this conditional, if two angles add up to be 180, they're supplementary. So if two angles add up to be 180, that's the hypothesis, then they're supplementary, that's the conclusion. So if we switch those, that's the converse. If two angles are supplementary, then they add up to be 180 degrees. So let's look at some of the angle pairs that we learned about last lesson. So this is a really official definition. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. I made all these more human definitions to make it a little bit easier. So if the lines are parallel, then corresponding angles are congruent. So that's what we learned before. If we know the lines are parallel, that means the corresponding angles have to be congruent. So this is how we wrote it. If the lines are parallel, then corresponding angles are congruent. Well, now they have another complicated definition. If two lines in a transversal form corresponding angles and are congruent, then the lines are parallel. So it's a little bit easier. If corresponding angles are congruent, then the lines are parallel. Again, we just switch the hypothesis and conclusion. So in this figure, if they tell us, we don't know that L and M are parallel, we have no idea, but they tell us angle 2 and angle 6 are congruent, and they are corresponding angles, that means that the lines have to be parallel. So we write it the same symbolic notation what we did over here. Corresponding angles are congruent if the lines are parallel, if corresponding angles are congruent, then the lines are parallel. Sorry, I almost said it backwards. If corresponding angles are congruent, then the lines are parallel. So as you can imagine, it's like that for all these. So before we did alternate interior angles. If the lines are parallel, then alternate interior angles are congruent. If lines are parallel, then alternate interior angles are congruent. And now we have the converse. If alternate interior angles are congruent, then the lines are parallel. So if we know angle 4 and angle 6 are congruent, they are alternate interior, that means the lines have to be parallel. So alternate interior angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. And alternate exterior, same way. If the lines are parallel, then alternate exterior angles are congruent. So again, we have that symbolic notation. Then the converse, if the alternate exterior angles are congruent, then the lines are parallel. So if 1 and 7 are congruent, those are alternate exterior angles. That means the lines have to be parallel. So back in the day, they used to make you take a compass or a protractor and you make a straight line, and then you make another straight line that kind of intersected that as your transversal, and then you use that protractor to make another parallel line to it. Just a little side note. And then again, the symbolic notation. Now the last one's a little bit different because remember, if the lines are parallel, then same side interior angles are supplementary, not congruent. That's the only one out of the 4 that we know that are not congruent. They're supplementary. I abbreviated that to SSI, same side interior. And again, the converse, if same side interior angles are, this should not say congruent, this should say supplementary. Sorry, I copy and pasted. Then the lines are parallel. So now they add up to be 180 degrees. That means they're supplementary, so they are parallel. And again, the converse of that symbolic notation. So I know this gets a little bit confusing because now you're asking yourself like, okay, so when do I say that it's the corresponding angles and when do I say it's the converse of corresponding angle theorem? When can you tell which one? Do you know the lines are parallel, or are you trying to prove that the lines are parallel? And that's really the difference. If you know the lines are parallel, you'll use the corresponding angle theorem. If you're trying to prove they're parallel, so you don't know that, then you're going to use the converse. But here's a better way to do it. Remember when we talked about biconditionals? Biconditionals is when the conditional and the converse are both true. So you can write it both ways, and we wrote it as this: P if and only if Q. So if the conditional is, if two angles add up to be 180 degrees, then the two angles are supplementary. The converse, if two angles are supplementary, then they add up to be 180 degrees. Those are both true, so you can rewrite it as this conditional. two angles add up to 180 degrees if and only if the two angles are supplementary. The reason this is nice is because now we can write corresponding angles like that. So if parallel lines are, if the lines are parallel, then corresponding angles are congruent. Then the converse is also true. Corresponding angles are congruent, then the lines are parallel. So if you write it this way with a biconditional, then it doesn't matter whether you're proving the lines are parallel or whether you know the lines are parallel. It doesn't make any difference. If you ever use the corresponding angle theorem, you can just do it that way, and that covers all of it. So that's how I'm going to be writing it for probably the rest of this chapter and the rest of this year. So that works for all of our angle pairs. And again, you can also write it the other way where you switch these. But just to stay consistent and simple, I always start the same. Parallel lines, biconditional. Parallel lines, double arrow. Parallel lines, both arrows. Parallel line, both arrows. And again, that means the lines are parallel if and only if corresponding angles are congruent. So this example one, we're proving the alternate exterior angles converse. So first off, I just thought of this because I messed this up a couple times. Since we're proving the alternate exterior angle, we're not using the alternate exterior angle. So I know if you look at this, you're like, well, you could just do this in one step. Well, we're not using the alternate exterior angle because we're trying to prove that. So given angle 1 is congruent to angle 2. So that is our given, and we're going to mark that on here with our little arc. Angle 2 is congruent to angle 3. They are vertical angles. That's the vertical angle theorem. I also marked those with one arc. So now everything with one arc in here is all congruent. So angle 1 is congruent to angle 3, because again, if you look at those arcs, but that's the transitive property. If angle 1 is congruent to angle 2 is congruent to angle 3, that means angle 1 and angle 3 are congruent. And again, if you want to test that theory, if you just want to make up a random number, so if you want to say 40, and again, I'm just making this up. If angle 1 is 40, well, if angle 1 and angle 2 are congruent, then angle 2 is 40. Well, if angle 2 and angle 3 are congruent, then angle 3 is 40. Well, if angle 1 is 40 and angle 3 is 40, then they're also congruent. Now, again, I just made that up off the top of my head. Don't start getting confused at where I got that number. So then the last one, that means M and N are parallel, and we know that because angle 1 and angle 3 are corresponding angles. But again, this is where if you just put corresponding angle theorem, technically it's incorrect. You'd have to put the converse of the corresponding angle theorem. But that's why we just do parallel. The biconditional arrow points both ways. Corresponding angles are congruent. Now, we are going to try to do, we'll do some proofs like this in the future, but we're trying to shy away from these fill-in-the-blank proofs and trying to do more proofs that are open-ended that you guys kind of have to start on your own. And again, the reason is because there's probably 12 different ways to do this proof, and we want to make sure you do it the way you want to do and try to get that critical thinking in. So the next one, we're going to try to decide which of these two lines are parallel. And these are two separate questions. So, or maybe not, I guess I don't know, but I'm going to look at them as two separate questions. So which of the following lines are parallel? So A and B for this one, they look parallel, but are they parallel? Well, they are because these are corresponding angles, and they're saying they are congruent. So A is parallel to B, and I know that because, again, it's the converse of the corresponding angle theorem. We're just going to write it as the biconditional. Lines are parallel if and only if corresponding angles are congruent. And you can obviously abbreviate this down however you want as long as I can tell what you're talking about. Now this one, it looks like A and B are parallel, but we can't tell because they're saying that these angles are congruent. That doesn't tell us those are a linear pair, but we don't know anything about them being congruent, and they're not any of our four angle pairs that we can use. And they doesn't tell us anything about this line B. Who knows? So we can't tell. Maybe they're parallel, but we can't tell, so we can say no conclusion. What is the one I used in class? Either way, if you put not parallel, technically they might be parallel, but they probably aren't. So if you put not parallel, I'll count that. Determinable. You can't determine it. It's not determinable to make it a big word. That's what I used in class. But again, if you just put not parallel, I'll accept that. Now it gets a little bit harder when we have four lines because which one are parallel? Are these parallel or are these parallel? How can you tell? Well, again, the thing we're going to focus on is what angles do we know? I know this angle and this angle. I don't know anything about these angles or these angles, so really that means I don't know anything about this line right here. So that line's out. So obviously it's not going to be that these lines are parallel because we can't tell anything about the other one. Now if you look at the ones we do know, those are alternate exterior angles and they're congruent. So since alternate exterior angles are congruent, that means Q is parallel to S, and I know that because the alternate exterior angles are congruent. And again, I always write that as a biconditional. And the last one's a little bit different because we have some rays and some segments. And I'm assuming these are point A, B, C, D. Maybe not, but that's how I'm going to write it. So again, we don't know anything about any angles here or here. So this line segment, we can't tell anything about if that's parallel or not. But we can tell these are, again, those look like corresponding angles. And since they're congruent, that means this line and this line are parallel. That means this is our transversal. That means A is parallel to B, and against the corresponding angle. So angles are parallel if and only if corresponding angles are congruent. Now this is a really interesting one because it looks like we've done this before, but this is actually brand new. But the thing is, before what they would say is before they would say U and V are parallel. So what's the missing angle? And now they're doing the opposite where they're saying, what's the missing angle that makes them parallel? But here's the thing, it's the same exact thing. Whether you say they're parallel or whether you say you want the angle to make them parallel, I know that these are same side interior, so to be parallel, they have to add up to be 180 degrees. So you can either solve this or you probably can tell just by looking at it, that angle has to be 110. So that angle question mark is 110. But how do we know that? Well, that is parallel line if and only if same side interior angles are congruent. Or sorry, supplementary, not congruent. Hopefully you were yelling at me through your computer screen that it's not. They add up to be 180. However, this one, these are alternate interior angles, so they have to be congruent. So to make those parallel, that question mark would have to be 52 degrees. And again, that's the parallel if and only if alternate interior angles, and those are congruent, not supplementary. So if we use what we just talked about, we can do some problems that are a little bit more complicated. What's the value of X that makes P parallel to Q? Well, again, line P and Q have to be parallel if the marked angles are congruent. So if they're congruent, that means we set them equal to each other. Congruent means they're equal measures. And we solve this. Now it's just an algebra problem. 34 is equal to 3x minus 2. Add 2. 36 is equal to 3x divided by 3. We get x is equal to 12. Now remember, with this, we haven't done this for a while, so remember, what are they asking for? They're asking us to solve for x, so we're good to go. If they didn't want us to solve for x, if they wanted the missing angles, we'd have to go in and plug 12 in for each of these and find out what those angles are. But again, it just asks for x, so we're done, but make sure you remember that. Make sure you keep that in mind. So this says you try on your own. If you want to pause it and do these on your own, you can, and then fast forward and watch these, but I'm going to do these fairly quickly. So is it possible to prove the lines P and Q are parallel? If so, state the postulate or the theorem. So yes, it is possible. So P is parallel to Q. And I know that because these are same side interior, but not only are they same side interior, they have to add up to be 180. A lot of people miss this one, or miss one similar to this. If instead of having 50 and 130, if I made it 50 and 140, a lot of people would say, oh, they're parallel. We know same side interior, but those don't add up to be 180. So make sure you're always taking the time to check to make sure it adds up to be 180. Then this one, these are corresponding angles, and they are congruent, 70 and 70. So P is parallel to Q. And we know that because, I guess I didn't say it on this side, sorry, on this one. This is same side interior angles are congruent. And this one is corresponding angles are congruent. Now the next one's a little bit more difficult, and I don't think you'll have one like this on the test because a lot of people say, well, we can't figure this out. We can't determine this one. It's not possible. Well, the thing is, these aren't corresponding. They're not alternate interior, alternate exterior, or same side interior, but we can still figure out some of this stuff. So one thing you can do, this is 75. Well, the vertical angle is also 75. Well, now 75 and 115, again, now we have same side interior angles. But you have to double check to see if they add up to be 180. Because if they don't add up to be 180, they're not going to work. So 115 plus 175 actually ends up being 190. Whoops, put the X too soon. So we came really close, but they do not add up to be 180. They are not supplementary, so not parallel. Now, number 4 is interesting because a lot of students get hung up on this because they say, well, we don't know X, so how do we know if this is right? Well, you don't have to know X because X is going to be the same. No matter what you sub in for X, it's always going to be the same. So if this is X and this is X, they're alternate exterior angles, so P has to be parallel to Q. So if you subbed in 4 for X or 100 for X, 4 are the same. 100 are the same. So we know those are parallel because the alternate exterior angles are congruent. Now this one, so these double arcs just mean that this double arc is congruent to this double arc, and they are congruent. They're vertical angles, so that's perfect, but it doesn't tell us anything about this line. Just like we said earlier, we don't know anything about these angles, so we don't know if they're parallel. So P is not parallel to Q, and I guess, again, you might say, well, they could be, but we can't determine that. So if you just say not parallel, that's fine. And last but not least, number 6, those are corresponding angles. So P is parallel to Q. Corresponding angles are congruent. And the next one, solve for X that make those parallel. So these are congruent because they are corresponding angles. So 3X is equal to 45. So divide both sides by 3. X is 15 for this one. Then this one, these are same side interior angles, and so the problem is a lot of people say 120 is equal to 2x plus 10, but they are not congruent. Those angles are not congruent. Same side interior means they're supplementary, so they add up to be 180 degrees. So you have to make sure you remember that was supplementary. It's the only one you have to do that for. So that's 2x is equal to 130. Whoops, not equal. 2x plus 130 when you combine your like terms. Subtract 130. 2x is equal to 50 divided by 2. X is equal to 25. And again, make sure you realize they're asking you to find X. They're not trying to have you find the missing angle, just solving for X. Then this one, again, we have alternate interior angles. So alternate interior angles are congruent. 80 is equal to 2x plus 20. Subtract 20. You get 60 is equal to 2x. Divide by 2. 30 is equal to x. Now, if you went through and you actually said that these number 7 was corresponding angles, so you did the biconditional for that and listed it out for all these, that's awesome. You didn't have to because it didn't tell us to do that. So the next one are these proofs. So for the following problems, use a proof, paragraph explanation with reasons, tick marks with the diagram and math symbols and notation, etc. So here's the thing with this. I want you guys to make it as close to a proof as possible, and my goal is to make you write as much as you can down, but then when I grade it, I'm going to be a lot more lenient than when we do a normal 2-column proof. So the first thing I'm going to do is real quickly, I'm going to do a 2-column proof for this one. Don't write this down. I just want to show you the difference, and I'm going to show you what it actually looks like. I'm going to do this a little bit more over here. Give me not enough space, sorry. So L is parallel to M, that's given. So we're trying to prove that angle 4 and angle 6 are congruent. But again, we're not using the alternate interior angle theorem. So the second step, So if you don't use the alternate interior angle theorem, if I know that they are parallel, I know that angle 4 and angle 3, actually let's do it this way. Angle 4 plus angle 3 is equal to 180. I know that because the linear pair postulate. Angle 4 and angle 3 make a straight line. That means angle 4 and angle 3 are supplementary. That's the definition of supplementary. And I'm going above and beyond with this, so I know some of you guys might watch and not like those steps, but that's okay. There's probably some other math teacher that's like, that's not right at all. I apologize. I'm just doing this as an example. Again, don't write this down yet. So then the fourth step is angle 3 plus angle 6 equals 180. And I guess those also should be the measure of angle 3, measure of angle 4, measure of angle 3. Anyway. And that is the same side interior, so that's what we talked about earlier. Same side interior angles are congruent. And again, I know this isn't exactly correct, but I'm just doing an example. That means 3 and 6 are supplementary. Again, that's this same side interior angle theorem says they're supplementary. And then 6, so that means angle 4 is congruent to angle 6 because that is the congruent supplement theorem. So I took some time to do that, and I apologize for wasting time. And again, I know that if you're a math professor or a teacher, I know I did not do it correctly, probably in some of these places. But I'm trying to give an example where this is a proof that does every little tiny step. And again, some of them aren't needed necessarily, and some of them are probably overlapping and not necessarily correct, but this is just for an example. So what I want you guys to do instead of that is make sure you're marking your diagram. So those are parallel, that's what it says. And they already marked them, they already had those little triangles, if you actually look on here. But then I want you to say, okay, so I know angle 4 and angle 3, rather than saying they add up to be 180, let's just say angle 4 and angle 3 are supplementary. And then I'm going to say that's the linear pair postulate. So I know they're supplementary because the linear pair postulate. Or you could say they add up to be 180 and not say they're supplementary. I don't care. If you forgot that vocab word, do it that way. So then over here, I know that angle 3 and angle 6 are same side interior angles. So that means they're supplementary. So the punchline, don't forget this, we're proving angle 4 is congruent to angle 6, and I know that because the congruent supplements theorem. And that says that if you have two angles supplementary to the same angle, those angles are congruent. So notice I used a lot less steps, and I didn't necessarily do it in a step-by-step process, but I justified why I did everything. 4 and 3 are supplementary. I told why. 3 and 6, they're same side interior. You could say that the other way around. You could say they're supplementary. If you did it this way, you'd have to say they're supplementary on this side and then say the reasoning on this side. And then the last but not least, I have my final proof and the reason. So that's the way I want you to do it. It's a little less formal, but again, you might look at it and say it's really, really similar, and it is. My goal, I would love it if you guys did a 2-column proof, but this way we can be a little bit more lenient. We don't have to be as proper and stuff, and that gives you a little bit more freedom. So that's how I'm going to do the rest of these. So angle 1 is equal to angle 7. So again, the first thing you should say with this in the 2-column proof is that means angle 1 is congruent to angle 7 by the definition of congruent. But you don't need to say that when you're doing it this way. If you want to, you can, because again, the more steps you can say, the better. But I'm just going to mark angle 1 and angle 7 are congruent. And we want to prove 3 and 5. So notice they don't tell us the A and B are parallel. So I know A and B are parallel, so A is parallel to B, and I know that because what we've been doing today, the alternate exterior angles are congruent. So once we know that, this is actually a pretty quick one if you know that, because then we know that all the other angle pairs are also going to work out. So 3 and 5 are alternate interior. So angle 3 is congruent, whoops, to angle 5. And it is again, I would do it this way. Alternate interior angles are congruent. Now that's just one way to do it. The first time I did this, I actually proved that angle 1 and angle 3 were congruent because of vertical angles. I proved angle 7 and angle 5 were congruent because of vertical angles. And then I said with the transitive property, that means angle 3 and angle 5 have to be congruent. So that's another way you can do it. And the last one, we know that give us that these two lines are parallel, so I like to mark those in there. Prove that angle 1 and angle 2 are supplementary. Well, I know angle 1 and angle 3 are congruent. It's congruent to angle 3, and that's because of the vertical angle theorem. Since we know these lines are parallel, you have to make sure you know that first, but since we know they're parallel, that means angle 2 and angle 3 are supplementary. And that is the same side interior angle, oops, are supplementary. So that means that angle 2 is congruent to angle 1, and I know that because of that congruence supplement theorem. Again, it says if you have two angles that are supplementary to the same angle, those two angles are congruent. So a little bit of a longer one, but there's a lot to cover and a lot to explain. If you have any questions, please make sure you let me know.